Hi everyone. In this session, we will discuss about the second approach, which is using the synchronization concept based upon synchronized block method. So, the synchronized block can be used to perform the synchronization on any specific resource of a specific method. For example, you assume that a method is having 50 lines of code. Out of the 50 lines of code, user wants to synchronize only the 5 lines of code. For that specific scenario, we can use synchronized block in the sense we can use a set of lines of code inside the curly braces. So this can be called a block. So this is the block of code. If user write all the lines of a method in the synchronized block, that means all 50 lines of the code in the method is written inside this block, then it is equivalent to the synchronized method. For example, here you see I am having the method compute, which is carrying a argument. Inside that, some number of lines are written here. After that, only I want to make this portion of the code as a synchronized lines. So this part of the code inside this method will be implementing the synchronization concept. The remaining code after this block and also before this block will not be synchronized. So in this scenario, we can use the synchronized block for users requirement. The scope of the synchronized block is smaller than the synchronized method, because only a part of the code in the method is implementing the synchronization concept. A Java synchronized block does not allow more than one thread to provide the access control to that this number of statements for providing or sharing the resource. The system performance may degrade because the slower working of the synchronized keyword in the block. So Java synchronized block is more efficient than a Java synchronized method, because here if the block is synchronized, only a part of code is blocked to provide or provide the accessibility to another waiting thread, so which is more efficient than a synchronized method. And we will see the example here. In this example, I want to print the multiplication table, uh, two tables. So for that, single object is handling by two threads. So if any one thread is accessing that action portion, it should successfully complete its task, then only that object to be allocated to another thread. So based upon that, here I'm going to print two multiplication tables. First multiplication table is to be printed for all the lines, then only that object should be allocated to another multiplication table thread. So as per that, here I am using the class with name multiply, then compute is the method. Inside that method, a part of code is availing the synchronization concept. That code is having this block of code. Synchronized is the keyword for this block, then current object is indicating by using this keyword, then which is having the action portion. So 5 lines of multiplication table will be printed. Then here the argument which is taking the table number and multiplied from 1 to 5. Okay, the range is from 1 to 5. Then multiplication value will be printed here. For each iteration, we are introducing 400 milliseconds delay for this printing. Right, during that time, another thread may access this object, but this cannot allocate the, I mean, release the object, because this method is synchronized. Okay, so for that, I am going to create the thread by using my thread one class, by using the facilities of thread class features. Then I'm creating the object t. So constructor is used, just it is assigning the value. Inside that, any thread, it is calling the my thread one. Okay, then it is computing the 15th table by passing this. Once it is called, the control will be passing over this method, synchronized method. Okay, that means the compute is available here, then it will be called, right? So the second class mythread2 is also created with the thread facilities by inheriting the thread class. Then here also I am using the constructor for the mythread1, just assigning the value for this by using this object. Then this is also having run method. Once it is called, this is also calling the compute method, right, by passing the value 16 for this thread. So based upon this, my expectation is here, expected output, first I have to print the 15th table 1 to 5. Okay, then 16th table 1 to 5. So here the object, single object which is created by using the class multiply. So both objects are accessed by using the two threads, right? First thread belongs to my thread 1, second thread is belongs to my thread 2. Okay, two classes are there. You look at here, my thread 1 is one class which is using thread 1, and my thread 2 which is using thread 2, but both are using same object. That object belongs to class multiply, right? So that's what given here. Then once I invoking the start method within the microseconds, right, the this t1 is getting the CPU accessibility. Then this is calling the run method. That run method belongs to my thread 1. Okay, so now my thread 1 run method is called. So in the my thread 1 we are having the run method here, this one. Okay, my thread 1, right? So which is calling the method compute with argument value 15. So 15 is passing over here. Then this block of code is synchronized, right, until here. Then which is taking the iteration 1 to 5. Then here table number is 15, right? 15 into 1, 15 into 2. So this value will be printed until 15 into 5. So that's what you look at here, we are getting first thread values. Then the uh, thread is successfully completed 5 iterations. Then object will be released from the thread t1. Then t2 is getting the object here. Through this, you see my thread true is the class for this t2. So now which is calling the run method which is available in the my thread 2. In the my thread 2 we are having run method, this one. So which is calling the compute with value 16. So now this value 16 is passing over here. Then now 16 is passing, this portion of the code is now synchronized block, which is also taking the iteration from 1 to 5. Then here which is printing the table number is here 16. So 16 into 1, 16 into 2 for second iteration until 5 iterations, 16 into 5. So this value will be printed here. Then after successful completion it will come to this portion of the code. Then there is no more lines, it will exit from the loop. So here you see the output of this run method is printing the 5 lines of code of the 16th table. So like that, the threads, more than one thread is accessing the same object, but that object is passing to the block, synchronized block. So synchronized block is releasing the object after completion of that particular thread, right? So this is the purpose of synchronized block in the multi-threading concept. Thanks for watching.